All right. Today what we're going to talk about is incomplete substitution. Okay, so what does that mean? We're going to take a look at the integral of x times the square root of 2x minus 1 dx. Okay. Here we still have the composition of a function times another function. Do you agree?
Yeah.
All right, but what's the issue?
The outside is the same degree as the inside.
All right. If you are going to try u to u substitution, what would you let u be? Okay. Our strategy has been this. U equals 2x minus 1. Right? Which means du is
2
dx.
Well, that doesn't work.
Now, I don't want you to panic too much because we can make this work. Okay? Now, we have dx right here.
We do.
So we can go ahead and make that 1/2 du because it's 2. Dx is 1/2 du. Du is 2dx.
Oh, okay. Nice.
Light bulb. All right. Now this is, I'm going to write u to the 1/2. Is that okay? So we have that x there. Is it okay? Everything right here is in terms of u. Is it possible to write this x right here in terms of u?
Yes. Yes.
Yes. Couldn't we say that u plus 1 and then divided by 2 is the same as x?
Oh,
And now we have an integral that we can actually go ahead and go through. Take the antiderivative. All right. So, first of all, okay, I'm telling you that this is possible. What are we going to have to do to integrate this?
You want to distribute first?
Okay, we don't have a product rule. Let's distribute. Can I multiply u to the 1/2 through?
Yes.
All right. Now, something else I'm going to do. I have a 1/2 right here. Can I make this a 1/4?
Yes.
All right. So u to the 1/2 times u would be what? U to the 3/2 plus u to the 1/2 times 1. All right. Now we have a very, very nice integral. Okay. So we have 1/4 times u to the 3/2 becomes what?
U or 2 or 5 times
U to the 5/2 divided by 5/2 plus u to the 1/2. That power becomes
U to the 3/2
divided by plus d. Once we integrate, that du goes away. Now, this.
I lost how you got the U.
Power rule. Oh, you mean these right here?
Yeah.
Okay, we took u to the 1/2 and multiplied it to u plus 1.
Okay. I got you.
Okay. Now, can we leave them as u's?
No.
What was u?
2x minus 1.
All right. So, u to the 5/2 is 2x minus 1 to the 5/2. All right. Now, it has a coefficient of 2/5 that's being multiplied to 1/4. Plus, this is u to the 3/2, so 2x minus 1 to the 3/2. U has a coefficient of 2/3 and it's being multiplied to 1/4. So there is our rewritten answer.
Now let's make sure that that derived becomes what we have.
Would you like to do that?
No.
Okay. Now, I will tell you that the back of the book is kind of crazy. And what they will do for their answer is factor out 2x minus 1 to the 3 halves.
Oh, that's...
Okay? And so the answers in the back of the book aren't very pretty. I would expect you to leave it here. Okay?
Yeah, that's not fine.
Is that how the AP test will do too?
The AP test doesn't care if you simplify. Okay? So they would let you leave this as 2 over 20 instead of 1/10. Things like that. Alright? Questions on this process?
Why is it called incomplete substitution?
Because when we substitute, we don't have, like when we
Oh,
replace,
because we don't completely substitute for it. Gotcha.
yes. Aaron figured out his own answer.
Yeah.
Alright, let's look at another one.
Just realized it's about 2 Does it matter for incomplete substitution which one we select to be our I guess that one's under a radical, so that would...
Okay. We still have to follow the same idea where we're looking for the composition. Okay? And so you would still need to go with the x plus 4 to be your u because it's inside of the 1 over square root of x function. Alright? So we would need to let u be x plus 4, which means du is what? Dx. Ooh. Not a problem. So we still have the integral. Dx becomes du because of this. The square root of x plus 4 becomes the square root of u. What about 2x plus 1?
Well, x equals u minus 4.
Okay, x is the same thing as u minus 4. So this becomes 2 times u minus 4 plus 1. We need to make this look a lot prettier if we want to do an integration.
2u minus 7.
2u minus 7.
And then move the u up. This for u up.
So you want me to write this as 2u minus 7, and then instead of divided by the square root of u, we should write
Yes, u to the negative 1/2.
u times u to the negative 1/2. Does everybody agree with that? And understand why we did that? Okay, we don't want a fraction. Okay, we need some nice power rules, some nice trig rules. Okay, so let's rewrite this as 2u to what power?
The 1/2.
Positive 1/2 minus 7u to the negative 1/2. Okay. So now we can finally integrate it. 2u to the 1/2, u to the 1/2 becomes u to the 3 halves, divided by 3 halves, and then we still have that coefficient of 2. Okay, minus u to the negative 1/2 becomes u to the
1/2.
positive 1/2, divided by 1/2, and then we still have our coefficient of 7. So we have 4/3 times u to the 3 halves. Well, u was x minus 4 or x plus 4?
X plus 4.
Minus 14 times u to the 1/2.
Plus.
Okay, and like I said, the back of the book's going to factor out x plus 4 to the highest power. So they factor out x plus 4 to the 1/2.
So then we'll be like,
You're not smart.
x plus 4 to 1/2 times 4/3 x plus 4/1 minus.
And they might factor out some of the coefficients too. It's very strange what they do. And it's more simplified because you're writing it as a product instead of a difference or sum. Okay? But we're just gonna leave it here. Okay? I'm gonna go ahead and stop this.
Stop.